so much gap. So in the last lecture, in the previous lecture, we have started our chapter number 5, that is psychometry, and we have completed the basic terms or basic terminology related to the psychometry. Then also, as a part of revision, I will go through that basic terminology within first 5 minutes, and after that we'll start our regular lecture. So we are knowing that whatever psychrometric chapter is there, psychrometry means it is the study of moist air. Psycho meaning is meaning of psycho is nothing but moist air, and metry means study. So study of moist air is called as the psychrometry. So whatever this chapter number 5 or whatever this psychrometric chapter is there, that is section that is called as the air conditioning. So we are saying that air conditioning means it is the conditioning of air, or it is the branch of science or engineering science which deals with conditioning of air. Now, what is the exact meaning of conditioning of air? Conditioning of air means we have to supply and maintain the internal desirable atmospheric condition irrespective of external condition. That means whatever may be the external atmospheric condition, irrespective of external atmospheric condition, if you are going to maintain the desirable internal atmospheric condition, this will be called as air conditioning. And to maintain those desirable internal atmospheric condition, we have to control 4 parameters simultaneously. Those are nothing but we have to maintain the temperature, humidity, then purification of air, and air moisture is nothing but air velocity. Then psychrometric terms we have gone through. So out of that, first one is nothing but the dry air. So what is in the dry air? So whatever surrounding air will be there, that surrounding air we are calling it as the air, but that air is in the dry air plus water vapor. So dry air consists nothing but it is a pure dry air. It is a pure dry air which is consisting of number of gases. So those number of gases might be nitrogen, oxygen, carbon dioxide, hydrogen, argon, neon, helium. So if the mixture of those many gases are there, only mixture of those many gases are there, then that will be called as a pure dry air. But we are knowing that on the Earth's surface, the pure dry air does not exist. So here afterwards, the word air will come. So that air is nothing but the moist air. That will not be the pure dry air. Now, second one is nothing but moist air. So what is by moist air? Moist air is a mixture of dry air plus water vapor. It is a mixture of dry air. So in the dry air, water vapor particles are available. Water vapor particles are mixed. Water vapor. If in the dry air, water vapor particles are mixed, then that air will be called as a moist air. So the amount of water vapor particles which are dissolved in the dry air, that will depend upon the temperature as well as pressure of that entire air. Temperature as well as pressure of that air. And here, whatever water particles are there, those are invisible to our eye. Why? Because water vapor particles are diffused in the dry air. Those are in the state of superheated vapor or in the saturated vapor. That's why those are invisible to our naked eye. But in the winter season, you might have the fog. So that fog is nothing but the excess amount of water vapor particles are there that mixed in dry air. Those are formed in the form of fog. That is called as a moist air. Then third one is called as saturated air. So as we are knowing that moist air is nothing but the dry air plus water vapor. So whatever dry air is there, that dry air is having the amount of water vapor containing ability, particular amount of water vapor containing ability. So if that ability of water vapor containing will get fulfilled, then that air will be called as a saturated air. So saturated air is nothing but it is a mixture of dry air plus water vapor. Saturated air is nothing but it is a mixture of dry air plus water vapor. The voice is clear? is breaking. Okay. Wait for 1 minute. Hello. Hello. Now whether voice is clear, please give the reply. Remaining student. Okay. So whether PPT is visible. Okay. So saturated air. So saturated air is nothing but it is a mixture of dry air and water vapor, or it is a mixture of dry air and water vapor when maximum possible amount of water vapor, when maximum possible amount of water vapors are diffused in a dry air, that will be called as a saturated air. Then next concept we have seen, that is nothing but the dry bulb temperature. So up till now we were knowing only one temperature, but here afterwards we should know near about 3 to 4 type of temperature. So out of that, first type of temperature is called as a dry bulb temperature. So what do you mean by dry bulb temperature? So dry bulb temperature is nothing but the temperature of air recorded by ordinary thermometer. Temperature of air recorded by ordinary thermometer when its sensing bulb is dry and clean. So here we are knowing that we are always measuring the temperature with the help of thermometer. And in that thermometer, so whatever mercury will be there, that mercury will be present in the sensing bulb. So if that sensing bulb of mercury, sensing bulb of thermometer is dry and clean, then the temperature of air measured by that particular ordinary thermometer will be called as a dry bulb temperature. So that dry bulb temperature will be denoted by dBT or TD or TDP. The next temperature is called as a wet bulb temperature. So wet bulb temperature means here when we are going to wound, suppose this is the thermometer. Assume that this is the thermometer and this is the sensing bulb. So if I'm going to wound this sensing bulb with the help of wet cloth, with the help of wet cloth, then whatever temperature of air will be measured by this thermometer when its sensing bulb is wounded or surrounded by the wet cloth. So that temperature will be called as a wet bulb temperature. So definition of wet bulb temperature, it is the temperature of air recorded by thermometer when its bulb or when its sensing bulb is surrounded by wet cloth or wet cloth exposed to the air. So that will be called as a wet bulb temperature. So next term is called as a wet bulb depression. So as dry bulb temperature is denoted by dBT, wet bulb temperature is denoted by WBT. That dry bulb temperature can also be denoted by TD, or that can also be denoted by TDB, dry bulb. And wet bulb temperature can be also denoted by TW. So here next term is called as a wet bulb depression. So wet bulb depression is nothing but simply it is the arithmetic difference between dry bulb temperature and wet bulb temperature at any point. So here for a particular point, if I am going to measure the dry bulb temperature as well as wet bulb temperature at the same time, for a particular point, if I am going to measure dry bulb temperature as well as wet bulb temperature at the same point or at the same time, then whatever the difference between dry bulb temperature and wet bulb temperature will be there, whatever difference between these two temperature will be there, that will be called as a wet bulb depression. So wet bulb depression is nothing but simply difference between dry bulb temperature and wet bulb temperature at any point. That wet bulb depression always indicate the relative humidity of the air. Wet bulb depression always indicate the relative humidity of the air. So one more thing, as university has declared the exam, that exam is going to conduct in the month of December. So if exam will be conducted in the month of December, and if those exam will be online exam, then there will be the chances, or there will be the probability that those exam will be of multiple choice question exam or objective type exam. So you need to study from the basic itself, because whatever objective questions will be there, those will, all the objective question will be asked based on the basic. So here, related to the wettable depression, which question may be asked? So here, whatever wettable depression will be there, that is indicating the relative humidity of the air. Wettable depression is indicating the relative humidity of the air. Then next term is there, that is called as the dew point temperature. Dew point temperature means, here you might have observed one thing. So whenever you are keeping ice inside the glass, and if you are going to keep that glass to the surrounding, then after some times you will observe that on the outer surface of that glass, there will be the small water droplet. There will be the formation of small water droplet. Why this is so? Here, if you are going to have the water, if you are having the glass, and inside that glass, suppose you are having the ice cube or ice. So here, after some times, you will observe that at the outer surface of the glass, there will be the formation of water droplet. So this is mainly because of the concept called as the dew point temperature. So why this is so? Because here, as inside the glass there is a ice, so the temperature of ice will be very much less. So whatever surface which is in contact with the ice, that surface will also have the temperature nearly equal to the ice temperature. And to that outer surface of the glass, there is a, in contact with that outer surface of glass, there is a air. So as that air is containing the dry air plus water vapor, so water vapor present inside that moist air will start to condensate, or will get condensate on the outer surface of the glass. And because of the same, you will observe that at the outer surface of glass there are formation of water droplet. So dew point temperature means, when you are going to cool the air, when you are going to cool the air, the temperature of that air will automatically goes on decreasing, and one point will come where water vapor present, in that moist air will start to condensate, so that point or that temperature will be called as a dew point temperature. So simply, definition of dew point temperature, it is the temperature of air, it is the temperature of air recorded by thermometer when the moisture or water vapor present in the moist air start to condensate. When water vapor present in the moist air start to condensate, that temperature will be called as the dew point temperature. So as we have seen the three temperature, dry bulb temperature, wet bulb temperature, dew point temperature. Here, dew point temperature will be denoted by, here dew point temperature will be denoted by TDP or DPT. Dew point temperature will be denoted by TDP or DPT. So you have to always keep in mind that for saturated air, as a multiple choice question, for saturated air, the value of dry bulb temperature will be equal to value of wet bulb temperature, which will be equal to value of dew point temperature. So for saturated air, value of dry bulb temperature is equal to value of wet bulb temperature, which is equal to value of dew point temperature, TDP. So this is also one more important point that you have to note. Then next term, after seeing the dew point temperature, next term is called as the dew point depression. Next term is nothing but the dew point depression. Suppose you are having a air, moist air, and for that moist air, at a particular time, you are going to measure the dry bulb temperature of that moist air. You are going to measure the dry bulb temperature, and after that, by cooling the air, you are going to measure the dew point temperature of the same air. If you are going to measure the dew point temperature of the same air, then the difference between dry bulb temperature and dew point temperature, the difference between dry bulb temperature and dew point temperature that will be called as the dew point depression. So dew point depression is nothing but the arithmetic difference between dry bulb temperature and dew point temperature, that will be called as the dew point depression. So dew point depression, which is equal to dBT minus dPT or TD minus TDP. Are you getting? Yes or no? Are you getting? Please write in the comment box. Yes or no? Hello? Okay. Now, next point is called as a humidity. So I think in the last lecture, we might have covered up to dew point depression, or whether humidity point was covered. Humidity, specific humidity, then degree of saturation or percentage humidity, and relative humidity. So here, first, there are different type of humidity. Up till now, we are knowing only one humidity. So, but there are basically three types of humidity. Out of that, first type of humidity is called as a, that is only called as a humidity. That is also called as a specific humidity, or that is also called as a humidity ratio. Or one more name is there, that is also called as a moisture content. One humidity, specific humidity ratio, or moisture content. That will be called as a, all the names are one and same, and that will be denoted by letter small w. That will be denoted by letter small w. Now suppose you are having particular amount of air. Suppose in one container, suppose this is one cylinder or one container, and in that container, suppose you are having particular amount of moist air, this much amount of moist air. So as that moist air is consisting of the, it is the mixture of dry air and water vapor. So from that particular amount of moist air, if you are going to calculate, or if you are going to measure mass of dry air, and if you are going to measure mass of water vapor, because that moist air is consisting the water vapor as well as dry air. So this is the particular amount of moist air which is present inside one container, and from that moist air, if you are going to measure mass of water vapor and mass of dry air, then the ratio of mass of water vapor, to the mass of dry air, in a particular amount of volume, or in a particular volume, humidity ratio or humidity or specific humidity or moisture content, that will be defined as, it is the ratio of mass of water vapor, to the mass of dry air in a given volume of moist air. That will be called as a humidity or specific humidity or humidity ratio or moisture content. So here small w is nothing but, it is the ratio of mass of water vapor to the mass of dry air in a given volume of moist air. So whatever unit of humidity or specific humidity or humidity ratio or moisture content will be there, that unit will be gram per kg of the dry air. Then second humidity, is called as a degree of saturation or percentage humidity. Second humidity is called as a degree of saturation or percentage humidity, and that will be denoted by letter mu. So mu. Second humidity called as a degree of saturation or percentage humidity, and that is denoted by letter mu. So here degree of saturation or percentage humidity is nothing but, it is the ratio of actual specific humidity. To the specific humidity of saturated air at the same temperature and same pressure. That means here, if you are going to take the ratio of specific humidity of moist air, small w of moist air, to the small w of saturated air, then that ratio, but here small w and small w of saturated air should be at the same temperature and same pressure. Then that ratio will be called as the degree of saturation or percentage humidity. So for your understanding purpose, consider the same example. Here in one container, wait for 1 minute. Okay. Consider one example. In a one container, suppose you are having, this is the, you are having moist air. So this is nothing but, entire is nothing but moist air. So as that moist air is consisting of the mass of water vapor and mass of dry air. So here we have measured the mass of water vapor and we have measured the mass of dry air. But actually this is the moist air. Actually this is the moist air. Whatever this air is there, that is called as a moist air. Now here I have to convert, here I have to convert the same moist air into saturated air. I have to convert this moist air into saturated air. So for conversion of moist air into saturated air, what I have to do now? I am going to add the water vapor particle. Here I am going to add the water vapor particle in that moist air. So when I am going to add the water vapor particle in the moist air, the after some times that moist air will become as a saturated air. Now suppose that moist air become as a saturated air. moist air saturated air कधी होणार आहे? ज्यावेळेस त्या ड्राय एअरची वॉटर होल्डिंग कॅपॅसिटी फुलफिल होईल. ड्राय एअरची वॉटर होल्डिंग कॅपॅसिटी फुलफिल होईल त्यावेळेस ती एअर कोणती होणार आहे? सॅच्युरेटेड एअर होणार आहे. आणि ते सॅच्युरेटेड एअर होण्यासाठी मला काय करावं लागणार आहे? ह्या ठिकाणी वॉटर वेपर ऍड करावं लागणार आहे. वॉटर वेपर ऍड करावं लागणार आहे. आणि वॉटर वेपर ऍड केल्यानंतर त्या ठिकाणी काय होणार आहे? मॉइस्ट एअरचं कन्व्हर्जन कशामध्ये होणार आहे? सॅच्युरेटेड एअर मध्ये होणार आहे. पण त्या ठिकाणी वॉटर वेपर ऍड करत असताना मला काय काळजी घ्यायची आहे? द टेम्परेचर as well as volume as well as pressure of that air should remain same. Temperature as well as pressure, not volume. We have to consider temperature and pressure. So temperature of that moist air as well as temperature of that saturated air should remain same. So after converging that moist air into saturated air, now again I have to measure the mass of dry air. I have to measure the mass of dry air of that saturated air and mass of water vapor of that saturated air. So here I have measured the mass of water vapor, mass of dry air of that moist air, and based on mass of water vapor and mass of dry air, I got the humidity or specific humidity of, here I got the humidity or specific humidity of moist air. And after converging that moist air into saturated air, again I have measured the mass of water vapor of that saturated air and mass of dry air in the saturated air. So the ratio of mass of water vapor to the mass of dry air in the saturated air will become as a specific humidity of the saturated air. So this ratio, that is actual specific humidity to the specific humidity of saturated air at the same temperature, that will be called as a degree of saturation or percentage humidity. So here degree of saturation or percentage humidity is nothing but mu, which is nothing but equal to W upon WS. Mu is equal to W upon WS. Now as far as multiple choice question is concerned, here one more important point. Here if I am going to consider the value of mu, so value of mu is equal to 0. If I am going to consider value of mu is equal to 0, what it will indicate? Value of mu is equal to 0 means here या ठिकाणी value of mu 0 कधी येणार आहे? ज्यावेळेस value of small w 0 असेल, या ठिकाणी small w ची व्हॅल्यू काय आली पाहिजे? 0 असायला पाहिजे. आणि जर small w ची व्हॅल्यू जर 0 असेल तर या ठिकाणी small w म्हणजे काय? स्मॉल w म्हणजे काय? मास ऑफ वॉटर वेपर डिवाइडेड बाय मास ऑफ ड्राय एअर. जर स्मॉल w इज इक्वल टू 0 असेल, स्मॉल w म्हणजे काय? मास ऑफ वॉटर वेपर डिवाइडेड बाय मास ऑफ ड्राय एअर विच इज इक्वल टू 0. जर मास ऑफ वॉटर वेपर डिवाइडेड बाय मास ऑफ ड्राय एअर इज इक्वल टू 0 असेल तर ह्याचा अर्थ काय असणार आहे, द व्हॅल्यू ऑफ mv शुड बी इक्वल टू 0. हे कधी पॉसिबल आहे, ज्यावेळेस mv इज इक्वल टू 0 असेल त्याच वेळेस हे पॉसिबल आहे. जर mv इज इक्वल टू 0 असेल, mv इज इक्वल टू 0 असेल, mv इज इक्वल टू 0 असेल, तर त्याचा अर्थ काय झाला, त्या मॉइस्ट एअर मध्ये वॉटर वेपरच प्रेझेंट नाहीत. याचा अर्थ काय झाला, मॉइस्ट एअर मध्ये वॉटर वेपरच प्रेझेंट नाहीत, म्हणजे ती एअर कोणती झाली, ड्राय एअर झाली. आर यू गेटिंग? दॅट मीन्स व्हॅल्यू ऑफ म्यू इज इक्वल टू 0 will indicate that value of mu is equal to 0 will indicate that the air is a pure dry air, or for pure dry air, or in reverse direction, for pure dry air the value of degree of saturation or percentage humidity is equal to 0. Are you getting? For pure dry air the value of degree of saturation or percentage humidity is equal to 0. Now another, if value of mu is equal to 1, if there will be value of mu is equal to 1, then what it will indicate? Value of mu is equal to 1 means here mu is nothing but W upon Ws. That means it will indicate that specific humidity of moist air divided by specific humidity of saturated air is equal to 1. When there will be the value of specific when this equation will be there, that means it will indicate that the value of W is nothing but equal to Ws. Value of W is nothing but equal to Ws. That means here moist air is nothing but saturated air. W is equal to Ws, but it will indicate that moist air is nothing but saturated air. That means here for saturated air, we have to always keep in mind that for saturated air the value of mu, that is nothing but degree of saturation or percentage humidity, is always equal to 1. Are you getting? Or in reverse direction, if value of mu is equal to 1, if value of mu is equal to 1, then that will indicate that the air is saturated air. Air is saturated air. समझते? Yes or no? Write in the comment box. What about remaining student? Okay, so this was related to the degree of saturation or percentage humidity. Now next term is there, that is called as a relative humidity. Next term is there, that is called as a relative humidity, and that relative humidity is denoted by letter phi. Relative humidity is denoted by letter phi. Wait for 1 minute. Whether my voice is clear? Yes or no? Whether PPTs are feasible? Okay. So next term is there, that is called as a relative humidity. Relative humidity that will be indicated by letter phi. So here for the understanding of relative humidity, take the same example. Initially in one container you are having a moist air. Suppose this is a moist air. So you have measured the, as that moist air is consisting of the water vapor and dry air, so you have measured the mass of water vapor and mass of dry air. Suppose here you have measured the mass of water vapor, you have measured the mass of dry air. Actually this is the moist air. This is the moist air. Now here I have to convert this moist air into saturated air. But while conversion of this moist air into saturated air, I have to take care that the the temperature as well as pressure of that air should remain same. So here I am going to convert, that means after adding the water vapor, after continuously adding the water vapor inside the moist air, I am going to convert that moist air into saturated air at the same temperature and same pressure. So now suppose here I have converted. Wait for 1 minute. Here I have converted that moist air into saturated air. So after conversion of moist air into saturated air, here again I have measured. Suppose here again I have measured the mass of water vapor of that saturated air, mass of water vapor of that saturated air, and mass of dry air of that saturated air. Mass of dry air of that saturated air. This is the saturated air. But while conversion of moist air into saturated air, I have taken care that the temperature as well as pressure should remain same. So here, after conversion of moist air into saturated air, if now I am going to measure, the mass of water vapor, if I am going to measure the mass of water vapor in the moist air and mass of water vapor in the saturated air, if I am going to measure the mass of water vapor in a moist air and mass of water vapor in a saturated air for a given volume of air at the same temperature and same pressure, then the ratio between that is nothing but ratio of mass of water vapor, in the moist air to the mass of water vapor in the saturated air. That ratio will be called as a relative humidity, and that will be denoted by letter phi. So the definition of relative humidity. So relative humidity will be always denoted by letter phi. Relative humidity will be always denoted by letter phi, and the definition is nothing but relative humidity is defined as it is the ratio of mass of water vapor in a given volume of moist air to the mass of water vapor in the same volume of saturated air. आपण काय केलेलं आहे, moist air चं कन्वर्जन कशामध्ये केलेलं आहे, सॅच्युरेटेड एअर मध्ये केलेलं आहे at the same temperature and same pressure. And relative humidity will be denoted by letter phi, that is also denoted by letter REH. That will be also denoted by letter REH. Are you getting? Here also, if value of phi is equal to 0, what it will indicate? Phi is equal to 0 कधी असेल, ज्यावेळेस mv is equal to 0 असेल. phi is equal to 0 कधी असेल, if mv is equal to 0 असेल त्यावेळेसच phi is equal to 0 असणार आहे. आणि mv is equal to 0 याचा अर्थ काय झाला, त्या मॉइस्ट एअर मध्ये वॉटर वेपर पार्टिकल्स प्रेझेंट नाहीत, म्हणजे ती एअर कोणती झाली, ड्राय एअर. सो फॉर प्युअर ड्राय एअर the value of relative humidity will be 0%. So relative humidity will be always indicated in terms of percentage. आपण बातम्या वगैरे पाहताना तिथं सांगतात बघा, रिलेटिव्ह ह्युमिडिटी ह्या ठिकाणी 60% आहे, 70% आहे, 35% आहे, 40% आहे. So that will be always denoted in terms of percentage. So here if phi is equal to 0, that will indicate the air is nothing but a dry air. And if phi is equal to 1, जर phi is equal to 1 असेल त्याचा अर्थ काय झाला, mv is equal to mv saturated, म्हणजेच काय झालं, ते मॉइस्ट एअर म्हणजेच काय, सॅच्युरेटेड एअर आहे. सो फॉर सॅच्युरेटेड एअर the value of phi will be equal to 100%. सॅच्युरेटेड एअर म्हणजे काय झालं, ज्या एअरची रिलेटिव्ह ह्युमिडिटी 100% आहे, ज्या एअरची रिलेटिव्ह ह्युमिडिटी 100% आहे त्याला मी काय म्हणणार आहे, सॅच्युरेटेड एअर म्हणणार आहे. आर यू गेटिंग? And if the value of phi will lies between 0% and 100%, 0 to 100 मध्ये असेल तर त्या एअरला मी काय म्हणणार आहे, मॉइस्ट एअर म्हणणार आहे. आर यू गेटिंग? If the value of phi will lies between 0 to 1, if the value of phi will lies between 0 to 1, म्हणजेच रिलेटिव्ह ह्युमिडिटी व्हॅल्यू किती, 0% ते 100%, त्या दोन्हीच्या मध्ये जर रिलेटिव्ह ह्युमिडिटी असेल एअरची तर त्या एअरला मी काय म्हणणार आहे, मॉइस्ट एअर म्हणणार आहे. Are you getting? So those were various psychrometric terms. One more term I think remaining, that is nothing but the enthalpy or total heat of the moist air. Enthalpy or total heat of the moist air. So we are knowing that enthalpy is nothing but the heat content of the body. That is nothing but total heat content of the body. Now suppose we are having the moist air. This as a moist air. So as that moist air is containing the water vapor as well as dry air, as that moist air is containing the water vapor as well as dry air, so that water vapor is also consisting of the heat or enthalpy, and dry air is also consisting the enthalpy. So here enthalpy or total heat of the moist air, enthalpy or total heat of the moist air is nothing but the addition of enthalpy of dry air plus enthalpy of water vapor. Simply काय enthalpy of moist air म्हणजेच काय, it is the mixture of dry air आणि water vapor. तर enthalpy of moist air म्हणजे काय असणार आहे, it is the addition of enthalpy of dry air plus enthalpy of water vapor present in that moist air. Are you getting? So that will be called as the enthalpy of moist air. So those were the various psychrometric terms which we have to use in this chapter. One more law we have to use, that is called as a Dalton's law of partial pressure. It is called as a Dalton's law of partial pressure. So this law, I think many of the students might be knowing this law, Dalton's law of partial pressure. If you are not knowing, so that law will be illustrated with the help of this example. Suppose you are having one gas. Suppose here we will consider we are having hydrogen. We are having hydrogen, and here that hydrogen is present in this container. This is the one container. This is the one container. So whatever hydrogen we are having, that hydrogen is having the temperature as a T and volume as a P. And if I am going to measure the pressure of that hydrogen, suppose that pressure of that hydrogen is nothing but P1. Now I am having another gas. Suppose I am having oxygen or carbon dioxide, anyone. Suppose I am having oxygen as a second gas, but here whatever oxygen I am having, that oxygen also having the same volume. Oxygen also having the same volume as a P and same temperature as that of hydrogen. हायड्रोजनचं जेवढं व्हॉल्यूम आहे आणि हायड्रोजनचं जेवढं टेम्परेचर आहे तेवढंच व्हॉल्यूम आणि टेम्परेचर कशाचं आहे, सेकंड गॅस म्हणजे ऑक्सिजनचं आहे. आता मी जर ह्या गॅस 1 मध्ये जर गॅस 2 मिक्स केला, जर मी काय करतोय आता ह्या ठिकाणी गॅस 1 मध्ये, अजून एक गोष्ट, व्हॉट एव्हर ऑक्सिजन आय एम हॅव्हिंग, सपोज दॅट ऑक्सिजन इज हॅव्हिंग द प्रेशर ॲज अ P2. हायड्रोजनचं प्रेशर किती होतं, P1 होतं. ऑक्सिजनचं प्रेशर किती आहे, P2 आहे. पण काय गोष्टी सेम आहेत, टेम्परेचर आणि व्हॉल्यूम दोन्ही गॅसचा काय सेमच आहे. जर मी आता हे दोन्ही गॅस जर तिसऱ्या सिलेंडर मध्ये मिक्स केले, पण तो तिसरा सिलेंडर घेताना काय करणार आहे मी, त्या सिलेंडरचा व्हॉल्यूम पण काय पाहिजे, सेमच पाहिजे. त्या दोन्ही सिलेंडरचा जो काय व्हॉल्यूम होता तेवढाच व्हॉल्यूम काय तिसऱ्या सिलेंडरचा पण आहे. मी सिम्पली काय करतोय, हायड्रोजन मध्ये किंवा पहिल्या गॅसमध्ये दुसरा गॅस मिक्स करतोय, पण पहिल्या गॅसमध्ये दुसरा गॅस मिक्स करत असताना मी कोणती काळजी घेणार आहे, व्हॉल्यूम आणि टेम्परेचर of that mixture should remain same. Volume as well as temperature of that mixture should remain same as that of individual gas. तर त्या केस मध्ये जे काय प्रेशर असणार आहे, त्या ठिकाणी जे काय प्रेशर असणार आहे ते प्रेशर म्हणजे काय असणार आहे, PT. That value of PT is nothing but P1 plus P2. Value of PT is nothing but P1 plus P2. So that will be called as the Dalton's law of partial pressure. So here I think you might have understood with the help of schematic diagram. But how to explain this Dalton's law of partial pressure with the help of statement? So the total pressure exerted by mixture of air and water vapor. आता हे कशाच्या टर्म मध्ये घेतोय आपण, इन टर्म्स ऑफ मॉइस्ट एअरच्या मध्ये घेतोय. मॉइस्ट एअर म्हणजे काय, वॉटर वेपर एज वेल एज ड्राय एअर. आता या ठिकाणी काय म्हणतोय मी, ही जी मॉइस्ट एअर आहे, सपोज हा मी काय कन्सिडर करतोय, this is nothing but moist air. Here gas 1 I am considering as a dry air and gas 2 I am considering as a water vapor. Likewise, so this Dalton's law of partial pressure can be stated as the total pressure exerted by mixture of air, that is nothing but dry air, and water vapor is equal to sum of pressure, which each constituent would exert if occupied the same space by itself. So that will be called as the Dalton's law of partial pressure. Have you understood? जर समजलं नसेल तर सिम्पली काय लक्षात ठेवायचं आहे, डाल्टन्स लॉ ऑफ पार्शियल प्रेशर म्हणजे काय, एखादं जर मिक्सचर असेल, मिक्सचरचं टोटल प्रेशर जर पीटी असेल तर तो मिक्सचर सेपरेट केल्यानंतर जेवढे कॉन्स्टिट्युएंट आहेत तेवढ्या कॉन्स्टिट्युएंट मध्ये सेपरेट केल्यानंतर जर ते कॉन्स्टिट्युएंटचं टेम्परेचर आणि व्हॉल्यूम सेम ठेवला तर त्यांचं जे काय प्रेशर असणार आहे इंडिव्हिज्युअलचं प्रेशर, ते इंडिव्हिज्युअलच्या प्रेशरची ऍडिशन म्हणजेच काय असणार आहे, त्या टोटल किंवा त्या मिक्सचरचं प्रेशर असणार आहे. सो दॅट विल बी कॉल्ड एज अ Dalton's law of partial pressure. Now, so those was related to the basic terms related to the psychrometry. Now here in this chapter we have to solve two types of problem. So first type of problem will be problems based on psychrometric relations, and second type of problem will be based on problems by using the psychrometric chart. By using the psychrometric chart, and first one is by using the psychrometric terms. So sorry, psychrometric relations. So before solving the problems based on psychrometric relations, we have to understand the basic formulas related to those psychrometric relations. So now we are going to see the derivation. So here we have to see the three derivation. Out of that, first derivation we have to see related to this. Here first derivation we are going to see that will be related to the specific humidity, that is also called as humidity, that is also called as a humidity ratio, or also called as a moisture content. So as we are knowing the definition, specific humidity or humidity ratio or moisture content is nothing but mass of water vapor to the mass of dry air, mass of water vapor to the mass of dry air in a given volume of moist air. Now म्हणजे ह्या ठिकाणी आपल्याला काय माहिती आहे, स्पेसिफिक ह्युमिडिटी स्मॉल डब्ल्यू, कुठे गेलं, specific humidity small w म्हणजे काय, it is the ratio of mass of water vapor to the mass of dry air in a given volume of moist air. Now if I am going to consider here, if I am going to consider PA, PA, TA, MA आणि RA म्हणजे काय, प्रेशर, व्हॉल्यूम, टेम्परेचर, मास आणि कॅरेक्टरिस्टिक गॅस कॉन्स्टंट फॉर ड्राय एअर, किंवा ह्या ठिकाणी तुम्ही काय म्हणू शकता, PDA, PDA, TDA, MDA आणि RDA म्हणजेच काय झालं, प्रेशर, व्हॉल्यूम, टेम्परेचर, मास आणि कॅरेक्टरिस्टिक गॅस कॉन्स्टंट फॉर ड्राय एअर. आणि सिमिलरली इफ आय एम गोइंग टू कन्सिडर PV, PV, TV, MV आणि RV, those are nothing but the corresponding value, means pressure, volume, temperature, mass आणि characteristic gas constant for the water vapor, for the water vapor. Then according to, we are going to assume that those gases, that means dry air as well as water vapor which are present in the moist air are acting as a perfect gases. Then according to perfect gas equation, according to perfect gas equation for dry air, we can write as a perfect gas equation काय, PV is equal to MRT. perfect gas म्हणजे काय, perfect gas equation म्हणजे काय, त्यालाच आपण काय म्हणतो, आयडियल गॅस इक्वेशन म्हणतो. सो PV is equal to MRT. जर मी हे परफेक्ट गॅस इक्वेशन ड्राय एअर साठी ऍप्लिकेबल केलं आणि सेम परफेक्ट गॅस इक्वेशन जर मी वॉटर वेपर साठी ऍप्लिकेबल केलं तर ड्राय एअर साठी प्रेशर म्हणजेच काय, PDA किंवा PA आहे, व्हॉल्यूम काय, VA आहे. सो PA इज इक्वल टू MA RA TA. आणि सिमिलरली वॉटर वेपर साठी प्रेशर म्हणजेच काय, PV झाला, व्हॉल्यूम म्हणजे काय झाला, PV झाला. सो फॉर वॉटर वेपर दॅट विल बी PV is equal to MV RV TV. So by assuming the dry air as well as water vapor present in a moist air are acting as the perfect gases or ideal gases, we have written the equation for perfect or ideal gases based on dry air and water vapor. Now if I am going to take the ratio of here, if I am going to take the ratio of this equation 2 and equation 3, if I am going to take the ratio of equation 2 and equation 3, that will become as a PA divided by PV is equal to MA RA TA divided by MV RV TV. आता या ठिकाणी बघा, ड्राय एअर साठी काय झालं आपल्याकडे, PA सॉरी divided by PV is equal to MARATA divided by MVRVTV. ह्या ठिकाणी आपण काय केलेलं आहे, एक इक्वेशन राहिलेलं ह्या ठिकाणी लिहिलं तुम्ही. Here, if I'm going to take the ratio of equation 2 and equation 3, then that equation will become as a PA divided by PV is equal to MARATA divided by MVRVTV. असं बनेल. PA divided by PV is equal to MARATA divided by MVRVTV. आता ह्या ठिकाणी आपण काय कन्सिडर केलेलं आहे, आपल्याकडे मॉइस्ट एअर आहे. आपण काय कन्सिडर केलेलं आहे, आपल्याकडे मॉइस्ट एअर आहे. आणि त्या मॉइस्ट एअर मध्ये काय आहे, मॉइस्ट एअर म्हणजे काय आपल्याकडे, इट इज द मिक्सचर ऑफ ड्राय एअर प्लस वॉटर वेपर. सपोज दिस इज नथिंग बट वॉटर वेपर and suppose this is nothing but dry air, and combinedly this will be called as a moist air. आता ह्या ठिकाणी जर बघितलं तुम्ही, आपल्याकडे जे काही मॉइस्ट एअर आहे त्या मॉइस्ट एअर मधलं वॉटर वेपरचं व्हॉल्यूम आणि ड्राय एअरचं व्हॉल्यूम दोन्हीचं व्हॉल्यूम काय सेम आहे. दॅट मीन्स हिअर व्हॅल्यू ऑफ VA इज इक्वल टू व्हॅल्यू ऑफ VB. VA काय इंडिकेट करतोय, त्या ठिकाणी जे काही ड्राय एअर आहे, सपोज हा कलर ड्राय एअर इंडिकेट करतो, त्या पर्टिक्युलर व्हॉल्यूम मध्ये जे काही ड्राय एअर आहे त्याचं व्हॉल्यूम किती आहे हे आहे, आणि त्यातलं असणारं वॉटर वेपरचं व्हॉल्यूम काय आहे सेमच आहे. म्हणजे काय झालं, PA इज इक्वल टू PV. आणि टेम्परेचर जर बघितलं, आता ह्या ठिकाणी ड्राय एअरचं टेम्परेचर आणि वॉटर वेपरचं टेम्परेचर दोन्हीचं सेम असणार आहे, कारण की दॅट टेम्परेचर इज नथिंग बट द टेम्परेचर ऑफ मॉइस्ट एअर. आता आपण टेम्परेचर ड्रायबल टेम्परेचर मेजर करतो, ड्रायबल थर्मोमीटरनं टेम्परेचर मेजर करतो. तर थर्मोमीटरनं टेम्परेचर मेजर करत असताना आपल्याला टोटल मॉइस्ट एअरचं टेम्परेचर भेटतं. आणि त्या टोटल मॉइस्ट एअरचं टेम्परेचर म्हणजे काय असतं, त्या ड्राय एअरचं पण टेम्परेचर आणि वॉटर वेपरचं पण टेम्परेचर दोन्हीचं पण टेम्परेचर काय असणार आहे सेमच असणार. दॅट मीन्स हिअर व्हॅल्यू ऑफ TA विल बी इक्वल टू व्हॅल्यू ऑफ TV. टू कीप इन माइंड दॅट PA इज इक्वल टू PV. ह्याचा अर्थ काय झाला, वॉटर वेपर आणि ड्राय एअर, त्या मॉइस्ट एअर मधलं जे काही वॉटर वेपर आहे आणि जे काही ड्राय एअर आहे त्या दोन्हीचं व्हॉल्यूम काय सेमच आहे. त्यामुळे काय झालं, PA इज इक्वल टू PV. आणि दोन्हीचं पण टेम्परेचर म्हणजे वॉटर वेपर आणि ड्राय एअरचं टेम्परेचर काय असणार आहे, सेम टेम्परेचर असणार आहे. तेच टेम्परेचर म्हणजे तुमचं कशाचं असणार आहे, मॉइस्ट एअरचं टेम्परेचर असणार आहे. सो हिअर इफ आय एम गोइंग टू कॅन्सल द टर्म PA अँड PV, कारण की आपल्याला काय माहित आहे, as PA is equal to PV and TA is equal to TV, that's why I'm going to cancel the term PA आणि PV काय करणार आहे मी कॅन्सल करणार आहे, आणि दुसरी कोणती टर्म कॅन्सल करणार आहे, TA आणि TV कॅन्सल करणार आहे. So here if I have to arrange this term in terms of MV divided by MA, कारण की मला काय पाहिजे, कशासाठीचं इक्वेशन फाइंड आउट करतोय मी, या ठिकाणी जे इक्वेशन मला फाइंड आउट करायचं आहे ते कशासाठीचं फाइंड आउट करायचं आहे, स्मॉल w म्हणजे ह्युमिडिटीचं इक्वेशन फाइंड आउट करायचं आहे. ह्युमिडिटी म्हणजेच काय, इट इज नथिंग बट दी मास ऑफ वॉटर वेपर डिवायडेड बाय मास ऑफ ड्राय एअर. या ठिकाणी आपण आता ड्राय एअर कशाने इंडिकेट केलेलं आहे, MA न. त्या ठिकाणी तुम्ही MDA न पण इंडिकेट करू शकता. तर मला काय करायचं आहे, आता हे जे इक्वेशन आहे 2 आणि 3चं डिवायडेशन केल्यानंतर या इक्वेशन मधलं मला काय पाहिजे, MV डिवायडेड बाय MA मध्ये व्हॅल्यू पाहिजे. सो आफ्टर रिअरेंजिंग द टर्म या ठिकाणी मी काय कॅन्सल केलेलं आहे, या ठिकाणी हे जे आहे त्या ठिकाणी तुम्ही हिथं कन्फ्युज होत असाल, हे ऑलरेडी कॅन्सल टर्म आहे, ह्याचा विचारच करू नका. PV divided by PA is equal to MVRVTV divided by MARATA. त्यापैकी PV आणि VA कॅन्सल केलं, TV आणि TA कॅन्सल झालं. त्यानंतर मला काय मिळेल, MV by MA is equal to ह्या स्टेपला दिसते, MV by MA is equal to काय मिळणार आहे मला, PV by PA इंटू RA by RV हे व्हॅल्यू भेटणार आहे. समजतं इथपर्यंत. आता या ठिकाणी RA काय इंडिकेट करते, हिअर RA इज इंडिकेटिंग द कॅरेक्टरिस्टिक गॅस कॉन्स्टंट फॉर द dry air. Ra is indicating the characteristic gas constant for the dry air, and the value of that is nothing but 0.287 kilojoule per kg Kelvin. And here RV is indicating the characteristic gas constant for the water vapor. RV is indicating the characteristic gas constant for the water vapor, and that value is nothing but 0.461 kilojoule per kg Kelvin. So here in the same equation, if I am going to put the value of Ra and if I am going to put the value of Rp, put the value of Ra as a 0.287 kilojoule per kg Kelvin, value of Rv as a 0.461 kilojoule per kg Kelvin. So here I will get the value of MA divided by, I will get the value of MV divided by MA. That is nothing but MV by MA. त्या ठिकाणी MA म्हणजेच काय, MDA. That is nothing but value of small w. So specific humidity will be given by equation, or humidity or moisture content or humidity ratio that will be given by equation 0.622 हा 0.622 कुठून आला, 0.287 डिवाइडेड बाय 0.461, याचा जो डिव्हिजन आहे तो काय असणार आहे 0.622 इंटू पीव्ही डिवाइडेड बाय पीए, so this mv by ma is called as a specific humidity. So this is one equation, but here in this same equation या ठिकाणी पीए म्हणजे काय, प्रेशर ऑफ ड्राय एअर. पीए इज नथिंग बट प्रेशर ऑफ ड्राय एअर. So PDA किंवा PA दोन्ही सेमच आहे. So here if I am going to take the barometric pressure or atmospheric pressure, barometric pressure म्हणजेच काय, if I am going to take barometric pressure or atmospheric pressure, barometric pressure म्हणजे काय, जे काय सराउंडिंग एअरचं प्रेशर आहे त्यालाच आपण काय म्हणतो, बारोमेट्रिक प्रेशर म्हणतो. सराउंडिंग एअर कोणते, मॉइस्ट एअर आहे. म्हणजे या ठिकाणी atmospheric pressure किंवा barometric pressure is nothing but it is the pressure of water vapor plus pressure of dry air. कारण की त्या मॉइस्ट एअर मध्ये काय, काय ड्राय एअर आणि वॉटर वेपर आहे. सो हियर P, total P, that is nothing but atmospheric pressure is nothing but PV plus PDA. त्या ठिकाणी जर मी PDA ची व्हॅल्यू कॅल्क्युलेट केली, PDA म्हणजेच काय, PA. So value of PDA will be equal to P minus PV. So here if I am going to put the value of PDA, which is nothing but value of PA as a P minus PV in this equation, I will get the value of small w. या ठिकाणी सेम सांगितलेलं आहे. जर मी P as a total pressure consider केलं तर टोटल प्रेशर म्हणजे काय असणार आहे, इट इज द पार्शियल प्रेशर ऑफ वॉटर वेपर प्लस पार्शियल प्रेशर ऑफ ड्राय एअर. त्यापैकी पार्शियल प्रेशर ऑफ वॉटर वेपर म्हणजे काय, PV, आणि पार्शियल प्रेशर ऑफ ड्राय एअर म्हणजे काय, PA किंवा PDA. त्यावरून मला कशाची व्हॅल्यू मिळाली, PA ची व्हॅल्यू मिळाली. PA इज नथिंग बट P मायनस PV. आणि जर मी ही PA ची व्हॅल्यू पाठीमागच्या इक्वेशन मध्ये पुटअप केली तर मला काय मिळेल, व्हॅल्यू ऑफ स्मॉल w, दॅट इज नथिंग बट रिलेटिव्ह ह्युमिडिटीची, स्पेसिफिक ह्युमिडिटीची व्हॅल्यू भेटेल. So specific humidity will be given by equation 0.622 PV divided by P minus PV. So here afterwards, that means whatever problem we are going to solve. So in that problem, we are going to find out the value of small w. Small w means specific humidity or humidity ratio or moisture content. That value we are going to find out by using the formula 0.622 PV divided by P minus PV. त्यापैकी PV चा अर्थ काय असणार आहे, here PV will indicate that partial pressure of water vapor. That PV will indicate that partial pressure of water vapor corresponding to dew point temperature. Partial pressure of water vapor corresponding to dew point temperature. ह्या ठिकाणी P चा अर्थ काय असेल, P will indicate that barometric pressure किंवा atmospheric pressure. म्हणजे जर तुम्हाला ऍटमॉस्फेरिक प्रेशर आणि जर पार्शियल प्रेशर ऑफ वॉटर वेपर जर माहित असेल तर त्यावरून तुम्हाला काय कॅल्क्युलेट करता येते, स्पेसिफिक ह्युमिडिटी किंवा ह्युमिडिटी रेशो कॅल्क्युलेट करता येतो. सो दिस वॉज फर्स्ट डेरिवेशन. सिमिलरली वी हॅव टू सी द अनदर टू डेरिवेशन. सो आउट ऑफ दॅट अनदर डेरिवेशन विल बी रिलेटेड टू द डिग्री ऑफ सॅच्युरेशन विच इज नथिंग बट म्यू, and third derivation will be related to the relative humidity which is nothing but phi. And after taking these two derivation we have to solve the problem based on the psychrometric relations. Now I think time is over. So you all have to write down the roll number. So while writing the roll number, write B space your roll number likewise, or and you can exit the lecture. But before exiting the lecture, so you have to keep in mind that the friends, your friends, which those who are not attending the lectures regularly, convey them message that 80% attendance is compulsory. If you are not going to attend the lecture, then you will not be allowed to, or you will be in the defaulter list. So simply you have to convey this message to your remaining friends also. If you have written the roll number in the chat box, you can exit the meeting. Thank you.